Good morning, guys. So, what are we going to discuss today? Um, earlier, so if you saw my thing, we're going to be drinking some wine just casually. Might as well, and discussing physics, whatever you guys would like. Any questions or anything like that. Um, so yeah, I have drank one of these of wine so far, and I have another one just served. I'm starting to feel it. So if you guys want to discuss the feelings of inebriation or anything like that, that is another aspect of reality that we can discuss. So good morning, guys. I'm just alive right now. Life is what it is, and I'm here to ask or answer any questions you guys wanna answer. I feel like I'm looking a little weird right now, but that's just self doubts, self reflections. How are you guys doing today? Good morning. What would you guys like to discuss? Or I guess I'll just talk about something that I was in preparation of what I was doing. So I wanted to explain degrees of freedom, and I wanted to explain like basics of quantum mechanics and basics of solving physics problems. Um, because I have two main questions that I'm currently working on in terms of like my videos. One of those questions is quantum teleportation and really the utility of that. That is sort of more about signal analysis, and that pretty much is all of quantum mechanics. So if you're ever wondering about like what quantum mechanics looks like, it honestly is just a lot of electrical signals. Because you guys may not realize this, but physics is just electrical. A lot of what we do is just electrical signals. So I'm glad there's a lot of people right now. I'm surprised. I'm surprised that there's a lot of people actually staying on here. So if you have any questions about physics or anything at all, that's what I'd like to do right now. In addition to drinking some wine. So I'm going to try to chug this thing right now so we can make this a quite entertaining process of discussion. I need a chaser, bro. I need a chaser. Okay. I'll just talk about the content first because we actually have a lot of people, so we're going to be educative, and then we'll be more banter and drinking. Okay. So we're gonna be more education. It does talk about CERN physics. Okay. Good point. Good point. What specifically would you like to know? So about CERN physics, and that was another thing that I have prepared. I wanted to talk about the limitations of physics. I'm not sure if what is it reversed for your side? Is this in reverse? Like, is it mirrored? If so, I can correct that because I can hold this and I can tap more and I can reverse the image. I've learned how to do that. All right, we're gonna reverse the image for you guys. Okay, looks like they removed the mirror setting. I'll do it later. So ask questions and I'll upload a video later today for you guys. But for now, I'm just gonna drink some wine and have some banter in addition to your questions. So please ask questions. I'll talk about what I have for you prepared on that end of CERN physics. Someone asked a question about quantum teleportation. That I wanted to talk about the issues with quantum mechanics and specifically about what it actually looks like in terms of that research. It mostly is just, you have to cool all your electrical circuits. The biggest thing that we fight in terms of quantum mechanics research is noise. Noise isn't actual okay, noise is a pretty good definition, and the reason why we choose the definition of noise is because noise is almost associated with vibrations, with audio. Noise is audio. But in terms of noise, in terms of like electrical outputs, electrical signals, it's thermal. Not only is it Not only is it thermal noise, not only is it vibrational noise, but it's electrical noise. So if I have a wire, such as this one, and it happens to have charge running through it, which it does, This wire is connected to my lamp, which is holding up my phone. Because there is charge, what are some of the electrical concerns finding the God particle, and what would be the consequences according to physics that's not talked about? There are no concerns with the God particle. The Higgs boson is simply a top-antitop pair. As far as my particle decay model, the Higgs boson is a boson. The boson, what that means is it's a particle that has even number spin. Even number spin means that it can hold the same state as others of the exact same quality, which is interesting. Bosons appear to have one even spin, and they also have the quality of quark antiquark. That's more about information theory, as well as more about measurement, but it's not necessarily useful for any discussions on what it is. The Higgs boson decays rapidly. It's kind of like mesons, which are two quark particles. So there's something called a K meson, which is, I believe, I can check my notes, but I don't have it just offhand. The K meson is, I believe, up and anti-strange, or down. You get me? It's like has that sort of property. But the more interesting mesons are pi mesons, which are up and anti-down. They have the exact same quality of a W plus or a W minus in terms of information, in terms of what you learn in particle physics, which I basically showed to my professor. But you know what I hate? It sounds so interesting, but my dumb brain can never comprehend. The thing is, particle physics itself doesn't require advanced physics. It really doesn't. I'm only referring to the Feynman diagrams. The Feynman diagrams that we use in particle physics does not require advanced physics. It only requires you to understand energy conservation and temporary violations of that. You don't have to do any calculations in terms of doing Feynman diagrams in order to prove that it's valid. But if you want to actually calculate rates, reaction probabilities, yes, you do need physics. But honestly, you don't need physics, you just need the equations which we gained from experimental analysis. If you could keep the highs from decaying, would you be able to create physical matter? Interesting question. I'm not sure what you mean by the highs from decaying. What are you accomplishing with this? I don't understand. Explain it like I'm 5. Okay, good question. So the thing with what I'm trying to do is I'm trying to expose information theory. I'm trying to not expose, but just share with you guys another aspect of viewing the world. Turns out the standard model is exactly how fundamental reality works. I have successfully mapped aerial combat, ground-based combat, and a little bit of martial arts combat. Anything that has a return state or a stable state can be broken up into these exchange rules of up, down, and what we're really trying to do is do protons. You're trying to write some state in the equivalent of proton, electron, and neutron. It's beautiful and fascinating to see that the way atoms exist in this world are equivalent to information in terms of things that are non-physical. A martial arts stance is equivalent to a proton. It's stable. If I shoot a punch, I swap into another state, but I have to return back to here. Return to my base stance. That is the example of a proton. If you try to decay a proton into another state, it's going to always come back to its original state, simply by how the particle decay rules work, which is interesting. We actually had to do that for one of our physics problems, like explain why the proton, using weak decay, cannot decay into why the proton doesn't decay, why the proton half-life decay is up to the order of 10 to the minus 32. Not minus 32, 10 to the positive 32. That basically means the proton is so stable that the likelihood for a proton to decay into another state that is stable would require so many particle reactions to occur in that order in order for a proton to switch into a different state. A proton is pretty much guaranteed to be stable. It's not actually stable. Nothing is stable. Guaranteed to be stable. It can decay into other stuff. But the probability of that decay happening is very rare. That's what you're going to get a lot of particle physicists that are like, it's actually decay rates and probability. Be like, okay, that's fine. What kind of fuel is required for the warp drive? Interesting. Good question. I believe, and that this is a weird one. Technically a warp drive has to have the qualities of being able to convert energy into momentum. Theoretically, that is possible with emission, light emission. That is one warp drive. Is it efficient? No. Is it slow as hell? Yes. In terms of the warp drive that you hear like meme physicists, like anybody with a PhD, there's this one guy called Dr. Blitz. He annoys me because yes, it's like a solar sail, but you can make your own. So you would have a solar sail, you would have a laser, you would shoot your laser, reflect, you get double the momentum. One, it goes away, and then the other goes that way. You get double the momentum in terms of pushing back, light pressure. But it's so small that laser solar sails are very, very much future tech. And the reason why they're future tech is only because of their heat limitations. We could make a laser solar sail now, but it's not worth it. There are lots of things like this that we know as physicists that the public can ask us, but we would say, I'm sorry, brother, it is not worth it. But why should I get money from basically telling you stuff that we know as physicists that's very simple? It's not simple to execute. Everybody will get pissed off if you say it's simple. Yes, it is simple to make a laser solar sail. It is not simple to make one that has everything that you need to make it viable. We can make solar sails for nanoparticles, like nanograms. If we really wanted to send like a single like maybe 100 nanograms to the speed of light somewhere else, we could probably do it for about 100, maybe $280 million. You could probably do that if you just want to send some nanogram payload somewhere off to the cosmos. And that is what the if you saw the most recent Cosmos, with Neil deGrasse Tyson, they basically talked about using solar sails with lasers on Earth to send them out. That is possible. The Higgs interacts to create physical matter, right? Okay. I don't like the Higgs boson. I don't like the way modern physicists talk so much about the Higgs field. I think it's irrelevant. I think what we really should be saying is there is some media in which all oscillating phenomenon must go through. There is some resistivity. What that means is there is something which will slow you down as you travel through space. And that is what the speed of light actually means. I actually have that written a little bit. I've been thinking about photons and how photons have the quality of quark-antiquark pairs, but they're not. They're not particles, which is fascinating. I wanted to ask a physicist at Lawrence Livermore Laboratory. It's a laser laboratory. I wanted to ask them specifically, from your experience, does a quark-antiquark pair is that useful in terms of photons? And if so, what I'm working at is that energy levels seem to follow my quark information model, and it seems to follow like these It's beautiful the way mass is equivalent to energy in terms of oscillation. It is fascinating when you see that it not only holds in terms of equations, E equals mc squared and E equals hf. It's not just equations, but it is a physical thing that does exist. So I theorize that the electron is actually an odd energy pair of quarks, of an up and an anti-down. It's an odd energy pair. The reason why electrons are so light is because they owe energy. That's also why they don't really have a pure wave or a pure particle behavior to them. They actually behave as two particles, which is beautiful, which is it shows up in terms of data. The Higgs interacts to create physical matter, right? In terms of conventional physics, yes, that's what they say. Not conventional, I mean modern physics, like the standard things that physicists talk about. They say the Higgs field is what creates matter, or creates mass. The Higgs field is almost like what you guys have heard colloquially as the ether, the diluminiferous ether. It's basically the Higgs field is just the ether renamed. It's that media which allows objects to oscillate in terms of their respective electrical, fields. That's what the Higgs is. Everything is a field. I don't like how they have 12 different fields. I think that's bullshit. I think we only need 2 fields. The weak field, and the electric field. Those are all you need to contain all the degrees of freedom of information that these particles hold. Physicists can argue a lot, and that's what I also wanted to make a shitposting video, basically saying like, I love this single electron theory, but thank you looking at oscillation now. Yeah, I believe electrons are actually odd energy pairs of quarks. And I have the actual, I can tell you what it is. So it's quite fascinating. Let me bring up the model. I have it in my notes, so might as well do it. Ask questions right now. Would we need a Dyson sphere to create a warp drive? Again, would a Dyson sphere be enough for warp capabilities? Here's the thing, brother. Just because you have unlimited energy does not mean you have enough to create a warp drive. The problem with a warp drive is it requires engineering. You now have engineering limitations. The limitations from engineering is thermal emission. You can't let your computer or your mechanics get too hot. If your mechanism gets too hot, it's going to, one, evaporate, as well as become less efficient, as well as explode. Your mechanism can explode. We don't want that. So even if you had unlimited energy, like fusion potential, even if you could have a fusion reactor on your warp drive, on your laser emission, even if you had that, you would have to contend with thermal processes, meaning there is a maximum rate, there is a maximum speed at which you could accelerate. There would have to be. There unfortunately is a maximum speed for everything. Does that mean a warp drive is out of the possibility? No, it means it is possible. If we did have unlimited energy, it just means we would have to accelerate at probably the rate of I'm guessing, just very rough estimate, we would probably be able to accelerate at maybe 0.01 or something like that, to the order of that, meters per second squared. That is not bad at all. Anything that is any amount of meters per second squared, which is acceleration, any acceleration which is greater than micrometers is good acceleration. So would a Dyson sphere be enough? We wouldn't need Dyson sphere. We wouldn't need a Dyson sphere specifically. We would just need fusion technology. So a Dyson sphere, the utility in that is you can actually transmit RF waves to do work. You can transmit RF waves, so radio signals, to actually power devices further in the solar system. The problem with that is that they have an energy conversion ratio of like 1 to 10%. 10% at most, only for small devices. 1% for devices larger than a few microwatts. And that sort of shows that Dyson spheres are theoretically terrible for the environment in terms of heat. But they're good in terms of, well, 0.1% of the sun's energy is enough to power our entire civilization right now. So even if we had a Dyson sphere around the sun, and we had everything powered by simply RF waves, by like radio signals, even if we had everything powered by radio signals, that's better than nothing. The sun's always going to produce that heat. So why not just use that heat to go power something else? That is the problem with Dyson spheres. There's nothing wrong with them. They work. They're theoretically possible, but they require maintenance that gets expensive and things like that. The engineering aspect of maintaining it and keeping it going is what bothers everyone in terms of making it practical and existent of a technology. Sort of like what nuclear energy is now. The waste is enough to limit their usage. Honestly, you're kind of right. Yeah. But nuclear energy, in my opinion, I think the downsides of the waste are definitely worth it still in order to meet energy demands on this planet. I think nuclear energy is fine. Wouldn't it pay for itself? I don't know. Honestly, I don't think the Dyson sphere would pay for itself. Because one, we would have to transmit our material to the sun, and get it as close as possible. Like, there is a way to engineer this. It's not out of the ordinary. It's not impossible. In fact, honestly, I should make a video on it. Like, fuck it. The cool thing about physics is that we work in terms of variables. Because we work in pure variables, all you have to do as the engineer is find the dy dx. The derivative of where it's equal to 0. That is the optimization point. I can basically write the equation in terms of heat. As you approach the sun, temperature goes up. As you approach the sun, you get more energy, which is like that's a function of a different thing, like square foot radius, something like that. You get me? It's called there's an actual word to it. It's like a square radian or steradian. Basically means like the amount of surface area that you get in terms of your solar panel. So as you approach the sun, it becomes more efficient to get closer, but it becomes less efficient because now you have to focus more energy on radiating that heat away. So there theoretically is a perfect distance away from our sun and our technology today that would make it efficient, or the best rate to do it. Yes, my grandfather worked for Johns Hopkins Applied Physics Laboratory. Sounds beautiful, man. Yeah, like applied physics, I think is the best thing ever. We're basically the engineers that design things. We actually design real things. Engineers are more about maintaining things. In all honesty. So, this is gross, but we're gonna go again. So far, I have, pretty much the whole thing to here. We're going to keep going. I'm feeling good. Any questions? Any questions so far? Or specifications you'd like me to consider? So I'll write that down. Your flow state for your mind is completely physics. You got to do great things. Keep this. Yeah. I'm right here with you, man. Yeah. The thing that's sad is that I really don't care too much about physics anymore. I care more about trying to love my family and people that I care about, and I want a wife, that's the thing, I don't want to become Newton. I don't want to become the next Isaac Newton, because Isaac Newton died with no women. He never had a kid. So I'm like, that sucks. But I did want to spread his legacy. So I wanted to talk about the Hamiltonian. I wanted to talk about the entire Hamiltonian. The thing about physics, about physicists, about not that. The thing about physics majors is that they'll often talk about simplifications, but they'll say like, oh, well, if we wanted to, we could use the exact solution. Okay. Do you know how to write the exact solution from scratch? You don't, obviously you're going to look it up. Someone's already done it. But do you understand how it works? That's what I wanted to do. I wanted to cover the exact solution in terms of the Hamiltonian and explain how it works. So the Hamiltonian tells you your total energy, and your total energy is equal to your kinetic energy and your potential energy. So far, sounds very simple. What is kinetic energy? Kinetic energy is actually equal to the radius or the speed away from total energy of what? Total energy of your system. If you know the total energy of your system and you know how potential energy is stored as you trade kinetic energy, if you know how these convert into each other, you know exactly how the particle is going to move. It's one of the most powerful tools of physics that I was like, wow, that's beautiful. My favorite thing in my physics classes was every time I would basically learn something new, I would say, there's no fucking way. The reason I said it so vulgarly is because that's what we said in the Marine Corps. It's like, there's no goddamn way that's gonna happen. But it's gonna happen. That's what happened in the Marine Corps. So, it's like, there's no goddamn way you're gonna fit that in your bag. But you're gonna fucking do it. So, pretty much is what happened with physics. It's like, you're telling me we can actually solve like potentials of 3D surfaces? There's no fucking way. We only have linear methods. There's no way. And they're like, my physics professor would be like, there is a way. And the way you calculate your surface potentials is to realize that there's another surface potential that matches exactly your function. Because it is continuous, you must have continuity. You must. And because continuity is preserved, what must happen? Vector potentials are equivalent. There is no discontinuity in the universe. There is, I will say it again, no discontinuity in the universe. These equations always work. I was like, damn. I fucking love that professor. That was my electrostatics professor. He was a freaking G. So when I asked him about like, it sounds like you can solve the F-35 problem. He's like, oh, aerodynamics? Oh, that's just electrostatics, but just with simplifications. No, I'm not interested in that. So I was like, okay, this guy's a freaking G. System is in my body. Used to figure out energy loss in systems and to show how you can make it better. Okay. The Hamiltonian is used specifically. Well, you could use the Hamiltonian to track energy loss. Good point. Actually, I didn't really think about that. But technically we do account for that. In terms of quantum mechanics, that is a big deal. What you just said, Chris Beckett. That is a big deal, and that is exactly how quantum mechanics works. That's called the perturbation theory, or the perturbation model. You write what you know works. You write what you know how to model the system as, in terms of, and that was another thing I want to talk about with oscillating photons specifically. So we know that there are energy states in terms of particles. You know, E1, E2, E3, E4. This is how an oscillating particle pair looks like in terms of them approaching each other. As you move away from the particle, well, you owe more energy because, you know, you're stuck together. But as you approach the particle, you guys are opposite, or the same charges, you know, opposite charges. So the potential energy goes up. You guys have to push each other apart. The cool thing is, okay, let me find my photon example. Okay. So that's the issue. That we're in terms of quantum mechanics, it's very close. We're very close because we don't have an exact solution. We don't know exactly what these particles are doing. That's why everything is so close. We're actually using approximations. The best approximation I saw in my physics class was using something called Fermi's golden rule, and there was another approximation, and it basically made something that we learn in physics 101, like not 101, but upper division physics, something called the quantum harmonic oscillator. I hate the quantum harmonic oscillator. It's bullshit. It's not reliable. It only has an accuracy of 78%. That's not good. Not good at all. 78%, close enough. But your energy values are off so much that it clearly is telling us that there's more to the situation. When our physics professor showed us how to use perturbation theory in terms of the cooler thing, the cool stuff that they use these days, it got up to a 98% accuracy. Still not perfect. Meaning these particles are not just doing what we think they're doing in terms of what we estimate as a quantum harmonic oscillator. They're not just oscillators. Yet they also have an additional sign component to them. So these are both going in and out of space on a separate rate and oscillating forward and backward relative to each other. There are clues in terms of these equations that tell us what is happening. The problem is most modern physicists are just trying to make their approximations get closer and closer to 100%. In terms of what we can do now, we have like a 99.8% accuracy. But is it an exact solution? No. Does it work for particles bigger than the hydrogen atom? No. It does not work for helium atoms. It does not work for anything larger than 1 proton and 1 electron. That's it. And we stop there because it's just unknowable. It's just too hard. I don't think it has to be that way. I think there must be a solution. So that is sort of the current state of physics. We're sort of waiting for someone to basically get pissed off and say, fuck these approximations, let's find the exact solution. You know, we're doing perturbation theory, and that works. Yeah, it works, but it only works for hydrogen atoms. Try to work for atoms like larger than helium, and you only get 92%, 90%, 91%. That's good. But it's not exactly to say, oh, well, there must be some perturbation in the model. There must be some perturbation in there. We can accept that perturbation as error from our signal and our integrity. So 91% for atoms larger than helium is good enough. 87% for atoms larger than proton 6, 6 carbon is good enough. 87, 86, 82 even sometimes. The model isn't good enough. We're almost there, but we're not good enough yet. So, yeah, that's another thing. Questions. I'm glad you guys are interested in this discourse. This wine is disgusting. Not as bad as others, but I don't like it. I thought it was gonna be smoother, so I accidentally spilled some. So, any questions, gentlemen? Any questions? I was sort of going off. I don't know if it was a tangent or not, but I do have these slides prepared. So just to restate, I have one prepared for quantum teleportation because someone asked that question. I'm basically going to explain that quantum teleportation is possible. It really should only be used for reconstructing mass. You're not going to clone things, but you know how teleportation is supposed to work? That is possible. We can actually transport particles from one place to another. You can take apart a key and make a key, the exact same key, in a different place, a different location. That is the purpose of quantum teleportation, to transport mass or matter. But you're not going to be transporting the matter itself. You're going to be transporting the information in order to reconstruct the matter that's over here to there. So it's almost like you have like 3D printing. Like you basically melt an object, you collect all its information from one side on the left, and you have the exact same atoms or like similar atoms available to you on the right, and you use that information to reconstruct it on the right side. Quantum teleportation is teleportation. We're trying to do that, but I don't think we're going to do that too soon. That's more like a technology we'll probably figure out in maybe 80 to 140 years from now. The reason why it's going to take so slow and so long is because we're not done yet reconstructing information in terms of the standard model up. We're not there yet. They're trying to figure out the techniques though. How do you finalize the equation? Which equation are you asking about? So knowing those states in quantum to recreate, it is huge actually. Yes. So it will be faster with AI and Ns. I don't know what AI and Ns are. With AI, yeah. So quantum teleportation is trying to, you carefully take apart something, you measure all their states relative to one another. Like it has a lot of code process figuring out. Like that's why neural networks, if we leave it up to a neural network, it will only work for specific sets or specific examples. It would not work in terms of general stuff. What I'm trying to say is that like this screen can display anything. It can display anything within these pixel set and that width, and it has the information to do so. If you use a neural network to generate a key, it can only generate what it is built to generate. So if we use a neural network to transmit a physical key, it won't be able to transmit anything else. That's why I think we have to figure out the information theory first. So that's why it's going to take a while. Because if you use neural networks to do it, yeah, it's going to work, but it's not safe enough in terms of like transmitting reliably. NASA say it can't figure out how a space part ended up on Mars that wasn't on Mars. Quantum telepo. NASA says can't how a space part ended up on Mars. Honestly, I don't trust in terms of that aspect of what you're saying in terms of like NASA putting something on Mars. The reason I say that is because there's a lot of disinformation about what NASA actually says and all this stuff. Like if you have an actual link on the website or any public statement, sure. But I think what that really is they're honestly I think they're messing with you. You saw it with the CERN physicist, that one. I can't say his name because he's trying to get you knocked off the air. Jabachim, I'll say that. I won't say it the way he thinks he should say it. That guy, the guy that I originally made my video on, like saying like, you see this? See how this works? Physics. That asshole. They're trying to put disinformation purposely out there. It's not necessary. You could say, yes, we do particle physics. No shit, you do particle physics at CERN. That's not the point. The point is, they talk about everything but the point. They're like, well, we measure the muons and we measure the decay rates into this wall. Yes, we know that. Undergraduate physicists are learning exactly how you do that, and they actually attend your seminars. They attend your lab stuff, and they intern there. So an undergraduate physicist without top secret security clearance will easily confirm, yes, they are measuring the decay particles. Yes, That is public information. We know that. The problem is, why are there discrepancies in terms of date? Why are there discrepancies in terms of lies? That's not necessary. The other discrepancy is, okay, you're doing this to advance the theory, but you know that the Higgs boson is the highest particle that has been theorized. What I'm trying to say now is that it seems pretty evident that what they're doing is what I'm saying they're doing. They're advancing what's called computational depth so quantum computers work by literally they send the signals to interfere with each other, and the way these signals interfere with each other actually reconstructs not exactly the particles, but the binary equivalent of these particles. If you have two upstates or two like blips and they interfere together, and you look at which state you're trying to measure, you're like, what is the data from this one? That's 3 cascades down. You look at that data and it basically tells you what happened. That's what's happening. We're just advancing quantum computer theory. So I think quantum computers do exist. They're being utilized, and they're being utilized by the governments of these nations that are funding the Large Hadron Collider, because the information only goes to those governments. No one else. Only if your government contributes and universities that contribute do they get the particle research. The thing is, most of these universities that contribute, do they know what's the utility of it? No. Maybe they don't. What's the missing link between quantum and relativity? That is what I was actually took the time to look at for a little bit. The missing link between quantum and relativity is specifically what everyone will tell you is what's it called? Quantum gravity. Is what is the potential between two particles as they travel a distance away from each other at the very small scale. I don't think it's too significant at the small scale. I think it's more about electrical. We know the electrical force is like 12 times stronger than the gravitational force in orders of magnitude, not just coefficient 12. It's 10 to the 12 times stronger. Okay, next question. With the Hamiltonian of the proton-electron system, how large is that system, local or global? That's actually a really good question. That's a good question because the proton-electron system, that Hamiltonian is estimated to be global. That's how the equations are actually written. The equations are written to basically say there's only a proton and electron. The hydrogen atom, there's only this. In reality, it's local. The problem is we can't have 2 hydrogen atoms together. If you have 2, the equation gets way too fucked of how quantum mechanics is currently written. And the reason why it takes such complicated computation that it's not even accurate, it's only like 86%. So it's 91% accuracy for a single hydrogen atom. The moment you add 2, or the moment you add more, accuracy goes down by 10% each one, up to like 63 for like certain distances. We approximate a lot in physics. And what happens when the accuracy is down to 63%? They add a perturbation that then corrects it. Like, oh, well, clearly we must be miscounting some energy potential that's equivalent to this. And that's all they leave it as. I'll show you how it works. It's so frustratingly bullshit. I'm going to write it real quick so I have it in my notes, because that's something I'm going to write down when I'm at work. Basically, when I'm at work, I'm writing these things out. So h of t, the Hamiltonian, x of t. The reason why we write Hamiltonian x of t is because we're trying to write as distance, space and time. We're going to remove time. You don't ever need time unless you're doing what's called a developing system or a dynamic system where things are moving. We're just going to deal with the standard system, because you do need the spatial derivative before you can add time. Because quantum mechanics is so cool that you can actually solve quantum mechanics with a stationary state and then add your your velocity perturbation. I think quantum mechanics is actually more beautiful than classical mechanics. It's more solvable in a weird way. It's beautiful. All right, so we're gonna write psi of x, what was the question? I'm gonna read it. Hamiltonian of proton electron system, global. Okay, yeah, okay. So we're gonna do psi of 1. We're gonna do psi of 2. That's some distance x2. Geez, we actually solved a double hydrogen system, and even that was fun. That was actually in our 115C. So that was our last upper division quantum mechanics course. So I can do a double hydrogen system. Even that is only like 81%. So I'm going to show you what happens at the end. They're basically at a plus V potential, and they say that is the perturbation. It's so frustrating. I'm purposely going to write 3. We're going to write 3 hydrogen atoms. So we're going to approximate a lithium atom, okay? We're going to approximate a lithium atom terribly. I think the approximation, if you use hydrogen modeling for a lithium atom, is like 60, even 53%. It's terrible. And then we add our Vx, or you can actually write it as, like, we don't have to write it as potential V. They can just write it as Ex or E of n, Ei. It doesn't matter because it's just some constant potential, constant energy perturbation. You just throw that bitch in. Does it change over distance and time? We don't know. You just pop it in. Oh, we were off by like what, 40%? Add in a 40% energy term. We're good. All right. Senior year undergrad physicist here. Damn, for real. So teleportation will only be a clone and never the actual thing. Okay, you understand what I'm talking about. If I delete this pen, and I record all the information that it takes to build it, and I delete it, and I have all the available materials some distance 10 miles away, I can recreate this pen. Boom. It is that previous pen. It has the exact same quantum information. You know, the same errors, the same scratches on it. It's the pen. Is it technically a clone? Yes. And like you just said, I'm purposely going to say a buzzword that PhD physicists love to say. The no cloning theorem will always hold. So there you go, PhD a-holes. You got what you wanted. Yes, it's just a clone. It's not the actual thing, but it pretty much is. Yeah, the original will be destroyed. I have some questions, some thoughts, but it's entirely too much to explain here. It's possible consciousness isn't physical matter, though the brain is. Good question. Good question. Can you explain what CERN is doing? How genuine are they? CERN is so they are doing genuine particle physics. There's nothing wrong with that. But what they're doing is their data is purposely advancing what's called computation depth. It's very beautiful, actually. So I'm going to give you a very rough visualization. Very rough. So here is like all like the scalar field, and you've heard that phrase. I've said it before, the scalar field. So here's the scalar field. This is zero. This is nothing. This is noise. This is everything that is without any order. Consciousness exists in pure information and information only. You can theoretically write consciousness in terms of molecules, in terms of information, in terms of states. You can. But the thing that's beautiful and weird about it is that, okay, I'll show you that. I'll show you that next. Okay, I'm gonna gotta write this, the zero order field, zeroth field. So I'm purposely gonna draw big for the very first stuff, but then it's gonna have to get smaller for others, because then it's gonna get, you know. Okay, so this is sort of what happens. What CERN is doing is they're basically they're discovering the fundamental information pairing in terms of particles and states of information. Okay. This is just one tree that is theoretically possible that exists somewhere. What this means is, so imagine this is like some two protons, you fuse them, they create like some atom or something like that. This is actually unstable because it's not an atom, it's like a macro particle, or like, it's a confusing hadron. It decays, it decays, it decays. The entire process is recorded in terms of their data. This can now be coded into a computer. It can be found if you see anything that has these similarities. It's like a link tree. It's like a node. If you know computer science, then you know how to utilize this. Oh, if I see the bottom of this tree and I verify that this exists, so if I have, so it's sort of like this. Let me show you how it works in terms of prepositional phrases. All right, I'm actually going to draw different colors. I'm going to say if on the bottom. I'm going to draw another color, output. All right. If you have all of these states in terms of your nodes, and we only care about this output, you can ignore this wasted computation and go to the output. Because you know this, and you can check the one state before, the last parent node. I'm going to put another color. Not that dark of a blue, a lighter blue. Last parent node, or last node. So if you have this at the bottom, and you only want this output, you check the last node before that output, you check the last particle, you see that, this is your output. You can skip all these other trees of nonsense, and you can go to the output. From just having this input, node detected, output, solution. It's changing the game of computer science. You can skip computations if you know how everything is written in terms of fundamental binary theory. That is what CERN does. There's nothing crazy about it. There's nothing wrong with that. But they're not telling the public. They're only sharing this with PhD computer scientists. If you know computer science and you know how to code, can you see what I mean? And this also can be broken down into what I discovered as the UD array. Because everything is just up and down particle, you can actually have some sort of array. I'm just going to write a random array. All right. Oh, damn. This is actually easier than I thought. Okay. Here. This is the solution. All right. If you have this array, 2, 3, 4, 2, in terms of up and down quarks and like, the antis, and you have this as your last node, 2, 1, 0, 2, then you just check the output. Output is this. Boom. All it is basically saying, if you know the bottom or the initial information, the history, if you know the past, and if you know what you want from the future, and you know what your last state was, what you're looking for, then you can extrapolate these two. You simplify the chain. That's the beauty of particle physics. You can skip information because you can.
Information, we don't have to say the whole freaking sentence for you to realize that. Okay, well, I'm going to try to give you an example of what that really means. Okay, if I am here, and so here's the thing. It's basically completing the sentence before it is said. If I am in a fighting stance and I throw a punch with a specific velocity that's very fast, that is knockout fast. If I throw a punch that's knockout fast in the correct direction towards my opponent's face, I don't need to ask any more questions. I know he's going to get knocked out. That is what computer science, that is what CERN's doing. That is what we've discovered. If, and I'm done. That's all I need to calculate. I don't need to simulate his entire body falling down. Oh, I don't have to. If, and I'm done. That's the future of computer science. If you have your previous states and you have your node, you know your output. They must decay. That is what we can do with particle physics. Like, I don't have to basically say, if I throw the punch, now I have to, like, does he knock out? Boom. He's falling down. I have to calculate everything as he goes down. No, I don't have to. It's a wasted computation. And a lot of physics is saving computation. That's what we do. We actually save a lot of computation space. Why did I look up for more information on that? Computational quantum mechanic. That honestly wouldn't be a bad search term, computational quantum mechanics. I would say you would have to look up quantum bits and how they're processed. How they're processed now is not to this degree of clarity. Not yet. Because what they're working with is interference patterns. They're not working with decays. Only those decay calculators that I have said in my other video can do decay modeling. If you don't use actual decays in a controlled manner, you're just going to be using interference patterns. You're basically shining light and they couple and they interfere, and you basically say, based on this pattern, I know these two bits interfered, and that is the output. What quantum computers are doing is they're basically saving calculations by looking at the interference pattern and saying, oh, of course 10 to the 32 times 8 to the 32 is that, because this cascading process results in that. Quantum computers are trying to save computation in terms of iterations, repeated iterations. They're not saving in terms of information density. Information density can be coded actually linearly. You don't have to use quantum computers for that. That's the problem. That's like it's a little, the modern science with quantum computers is a little less than the reality of it. Like, oh man, these things are going to be awesome. They're actually kind of interference computers for now. If you look at how they're built, they're interference computers. So they can solve math, but they sort of can't yet solve things that you don't know how to code into iterative math. You have to learn how to code for them. You have to know how to ask questions for them. Okay. The atoms CERN is finding, are they coming from our dimension or another dimension? Our dimension. Or another dimension. Doesn't matter. So as energy goes through our universe, the thing is, these come out of particles. These come out of our particles that they slam together, and it gets detected on the detectors. It's from our particles. I think they're from our universe. They don't have to be from another, so they're not. Where do our decisions go that are never committed to? Or do we go somewhere? Why isn't CERN sharing this info with the public? Are they corrupt? They're not sharing this information with the public, and the thing that I'm really wondering why, I think they're trying to save a computational advantage between NATO countries and China. It really is just a war of information. If China knew how to implement this information saving technique, they wouldn't know how to use it. But I explained how to use it. You can basically create like chess solvers. Like all this is what I call OODA loop. So there's a term in the military called OODA loop. Orient, observe, or observe, orient, act, decide. That's how you act in a battle. You orient yourself, you observe, you act, and then you decide. Pretty much the exact same thing happens with particle physics. You have to orient, you have to figure out how to how to describe everything in terms of these up, down, and these binary cascades. If you can do that though, you can be like, oh shit, the plane is going up, he's in this state, I know what I can do as my counter state. That's it. If you know how to write in terms of the particle physics model, you can solve the Ouroboros, and you basically have the solution. There's always the best solution for any action. If I swipe a punch at you, well, there has to be a best solution. There is a best solution. And particle physics tells us that, how to find the best solution. So if you don't know how to find the best solution, use the particle physics model and you'll find it. What are some good avenues to get into higher education in the quantum physics field? In terms of quantum physics, besides actually learning how to build on these textbooks and use them on your own, a degree or some education, formal education in doing these calculations. Because in terms of experiments, yes, it's just these calculations. There's nothing special about the calculations. You just do the calculations. They're not hard. Yes, they're hard, but they're possible. In order to advance the field, in order to understand how to utilize the field, you need to sort of know what the engineering limitations are. So the cool thing about physics, about undergraduate physics, is that you learn a lot about if you ask questions, like, okay, I get it. We somehow got to particle physics, but how did we do that? And then your professors say, while you're going through the class, like, well, you're right, good question. How did we discover this? We had to learn as physicists how to engineer smaller and smaller, how to become more and more precise, how to use electrical information, how to create sensors. So a physics class, a physics degree, teaches you how to develop sensors, how to build sensors that have your degree of precision. So I think physics is one of the best degrees you can ever have, especially if you go to a good university with professors that actually build sensors for their independent experiments. They're like, oh, coaxial cable, that's just a part, but the sensor, that's the real physics. Not really. You just have to learn how to convert motion, the tiny electric perturbation, into a voltage signal. And that is what you'll learn. I think the next steps in science is a shift in our understanding of consciousness. I agree. How can we reach higher dimensions? You can reach higher dimensions right now by realizing and understanding what they are. Higher dimensions are just informational constructs. This, in my opinion, is a higher dimension. What I'm trying to say is it has more degrees of freedom in this paper of notes, in terms of this is literally math, matrices. This has a lot of degrees of freedom. Another aspect of degrees of freedom is understanding that the world you live in right now, this thing that physicists are kind of stupid, that they don't really understand these things. Relativity is basically saying that the distance between any two objects, time is space. Time is space. So the distance between me and my phone is a physical space. It requires time for me to get closer to my phone. So what I'm trying to say is relativity is actually very sad. Relativity is depressing when you really understand what it means. Because there is wine in this. There is alcohol in this. In order for me to feel the effects, I have to wait for some relativistic time to occur, some distance. There is distance between action and event. That's all this is. Everything is just information. Realize that everything is information, and you can start appreciating the physical distances between you and another person. There's no way you have this same cup. There's no way. I swear to God, if you do, there's no way. I would love to meet you. Oh, I'm no longer in the unit, but yeah. That's why I got my hair longer and all this stuff. Gordy Rose, founder of D-Wave, working on that. How do you isolate a particle to send it through the Hadron Collider? That's actually a good question. One, you can ionize particles. You heat them up really, really, really hot, and they're basically such a high pressure that you have a tiny, tiny, tiny hole. They come out of that tiny hole, and what the reason they isolate specific particles is by mass. It's not too difficult. The thing that's funny is that when I made in my video, it's basic particle physics. It is basic physics because it's just E and M. Do you remember do you not remember your force equation from your particle or your charged particle through a magnetic field? It's B cross F. Ugh. And what happens is at regularly spaced intervals, your particle goes through a calibration, a thing, and if it's a little bit to the right, well, your sensors can actually detect that. Oh, it's a little bit on the right. So the next time it passes, you add a little bit more charge, and it ends up where it should be. Okay, that's good. And the next time it passes through the calibration sensors, a little bit on the left. That's okay. Decrease the charge over here, increase a little charge here, so then the next one it goes through right through the center. And it takes just a few of those to really get it lined up and calibrated. It's not impossible. All right. Are you describing many worlds interpretation, brands to reality from our own? You have a favorite physicist? Yes, I do have a favorite physicist. It used to be Michio Kaku, but his obfuscations on alien stuff, alien technology, kind of pissed me off. So he used to be my favorite one because he was very smart, but he is still very smart. But him going down string theory disappointed me. I don't think string theory is legit. It's useful only in terms like a concept of of course I would love for there to be like some fundamental node, but string theory doesn't work well enough that it's like, okay, how do you account for these other stuff? Well, you see, there's actually 12 different dimensions for these fundamental node strings, and they all interact with the Cabibbo matrix from particle physics. Like, it works, bro. It works. Trust. It doesn't. The fact you have to add 12, no, I don't think that shit is necessary. Why is relativity depressing? Relativity is depressing because it basically says that for everything that exists, there is a fundamental informational distance between you and that object. In order for me to explain to you what my notes are, that takes some time. That takes some time and some distance. The distance is your mind. The distance is however long it takes you to understand this, and the time is variable. If you understand it fast, your time is short. You're traveling fast. If it takes you a long time to understand this fundamental distance between you and I, different for each person, then the time is larger. Relativity is depressing because you start realizing that me and my work, I'm 23 miles away from my job. 23. In terms of time, like I have to travel that distance. Like it's I don't know, it's hard to describe, I guess. It's basically time is equal to distance in space. It is. Just realize that. The distance between me and my partner, me and my lover, is a physical thing. And that time has to be commuted. There's no way to avoid it. There are things like that. And that is why I think relativity is pretty depressing. It basically reminds you that, oh yeah, every time you walk away from me, that actually adds more time that it takes for me to find you. More time that it takes for me to meet you. More time that it takes for me to get to you again. That's why I think relativity is depressing. Are there multiple versions of myself with the same consciousness? Okay, what do you mean by that? Dude, I am not feeling this wine anymore, man. Like it's you know, it's going by too easy. I gotta chug this one. Yes, I do. I do need my own lab. Are there multiple versions of myself with the same consciousness? Okay. I have a question. I have a question for you. So, do I exist elsewhere? Oh, okay. So you mean in this universe? Okay. In this universe, yes. Honestly, I think you do. I think you. I don't think you do. You have your exact memories, but in terms of like your emotion and your base instincts and your base desires, yes, there's actually quite a lot of us, like I've noticed that, like it's beautiful. It's like stand user theory. What's the most interesting theoretical physics? The more alcohol, the more fun math physics combos get. Absolutely. So just for that, we're gonna pour more. Oh damn, that's the bottle, bro. Okay. So who's true? What's the most interesting theoretical physics? I think the most interesting theoretical physics is that our minds are binary and that we're what actually happened. Okay, it's not theoretical. That's the thing that pisses me off. It's not theoretical. It is what's happening. So because our mind is binary, because we can be binary, because you can actually figure out that you can correlate people to their likes and their dislikes, you can actually track revolutionaries. You can track dissidents. You can track terrorists. You can track people that are evil. You can track people that you don't like in society by what they like, by the similarities to the people that are like them. The thing is, man, I made a video about that, about using the TikTok algorithm to track consciousness. I believe that is what they're doing. That's what I'm saying. The CERN research also enables that by actually tracking everything as bits. Let me show you what I mean. So this is for calculations. This is a small particle chain. Let me show you a big particle chain, okay? So, exact same thing. We have the zero order field. That is nothing. That is noise. You always have to write it though. It must be written because it actually has utility. That's like neutral, negative. That's where the baseline is. The zero order field is where that's the average. So I'm gonna try to draw some zigzags. A lot of people might be over here. A lot of different thoughts. But you might get one that travels in just a weird way that you don't like. Okay. There theoretically exists a node. So a lot of people might be somewhere around here, like they're just existing, but you could theoretically discover some node, some like area of where people slowly, like their thoughts culminate to this trigger. This trigger basically says like this person is going to commit a mass and a mass in which people and when that happens, that's bad. But it's possible that you can find people that have very similar interests and likes to that. And that's the possibility, and that's what I believe the CIA has been doing since the 80s about trying to figure out. Okay, so who is true? Do you think God exists? That's a really interesting question about God. It's weird. Like my thoughts on like the universe and religions is that we're always gonna loop, because no matter what. Yes, it is called Project Looking Glass. I have heard about it, and yes, I do think that it is possible to calculate very generally and broad binary cascades for society, and I believe that is what they've been doing. Yes, yes, Project Looking Glass is a thing. Does God exist? That's a weird question. You can find that through social media easily. Okay, does God exist? The thing is, I'm very caught up on that. I think the soul lost its course with those guys. Have you ever approached this from a social psychology and communication perspective? Yes, I have actually. In terms of not social psychology, well, technically psychology and communication. Yes, absolutely, brother. Hope you have a good rest of your day and abundance as well. Have you ever got it down to the time and how you die? They even got it down to the time and how you die. Well, that would be fascinating. I do think that is possible. That would suck though, because it would probably only work for deaths that are caused by accidents or murder, in my opinion. I don't think that would work for natural death. No, I don't think it theoretically could for natural death. Like, unless you had an exact corollary or an exact, not corollary, but cause of death. Like, if you ate a certain amount of chicken nuggets, your lifespan decreases because your likelihood of what's it called, like blood sugar levels or whatever the hell, like increases. So unless that happens, you're not likely to be having natural causes of death like that. Keep elevating your value, your articulate, intellectual inclination within you, my friend. Yes, brother. Yes. The thing about God. Yes and no. I think, and it's weird. I feel like I've talked about this, but I haven't, because I don't know how to describe to you guys other than like what I see in my head. So what I was trying to say about there's a 2D. There's a 2D. So we live in a 2D universe. I know that sounds weird, but just follow along for now. We live in a binary universe, not a 2D, but a binary universe. All right. Which technically is 2D in terms of linear algebra, but let's not let the algebra or linear algebra people get up on us. We live in a binary universe. And the weird thing is, we actually live in a dual binary universe. But that doesn't necessarily matter, because binary just means that you can say one thing in terms of another. So we live in a binary universe, and what that enables is a dual binary universe. So we can now say there is a 0 or a 1, and there is a 0 or a 1. Which that now lets this happen. 0 or 1, or a 0 or a 1. Wow, fascinating. Nothing is violated yet. And now I'm going to translate that in terms of particle physics. We're going to add an up, we're going to add a down. So all I did was say everything is written in terms of up, everything is written in terms of down. Wow, that's consistent. Let me add another thing about shows we're in a binary universe. You can do the gradient of parallel fields, which is grad of divergence or divergence. Grad dot is divergence, or grad curl. So div curl. Boom. So now we basically said mathematically the universe is also only divergence or curl. That's weird. So everything follows in our universe at the most fundamental level just binary. We live in a binary universe. No matter what, everything can be broken into binary statements. There does theoretically exist ternary universes, exist quaternary universes, but we don't live in those. Those are higher dimension universes that require ternary states. That's why we actually live in the most anthropological, what's called the anthropic principle. We live in the most likely universe to exist in. We live in a binary universe. That's good, actually. That's good that we live in a binary universe because we're not violating any anthropic principle. If we lived in a ternary universe where the fundamental particles existed in 3 states, up, down, and whatever the heck, if they lived in positive, negative, and some third state, if it required these 3 things to exist, well, we would live in a ternary universe. But we don't. We live in a binary universe. It's fascinating. How do you jump into the next consciousness state? You don't jump into it. I'm sorry, I gotta drink some water. That wine is disgusting. It's not that nasty. I'm starting to feel it now. Starting to feel it, gentlemen. Like quantum jumping. Okay. Quantum jumping is sort of like, what is this cup? This is the cup. This is the cup. Okay. I'm gonna take a short break, and we're just gonna silver one. What is this one? It's Mio. I put Mio in there. Yeah. This dude needs more views. Well, it's up to you, man. I'm gonna upload this to YouTube. Yeah, what I usually do after lives, just because I like ensuring that the content was discussed. Where do you all go to school? What are you studying? I went to UCLA. Yeah. I learned a lot of physics there. I spent my whole undergrad actually studying. I'm at UCSD studying math comp sci. Well, brother, lucky for you, I live right next to UCSD. I live in La Jolla. So, yeah, if you wanna meet up, I would love to, I don't know, just discuss these for a little bit. Probably not too long, maybe like 30 minutes at most. I studied in the Air Force. Nice. That's really good. I originally wanted to become an F-35 pilot, but I didn't want to do that. Well, one, because the work-life balance was a little like not good enough. So I quit the officer program. I went to OCS for the first half of summer, but then I quit the program because I originally at the time I had a girlfriend, and she was amazing, and I wanted to dedicate more of my life with her, and so that's why I got a taste of doing physics in the civilian world, and I felt like I can contribute more to humanity by doing physics in the civilian world than I could by being a pilot in the Marine Corps. Nothing wrong with it. I definitely could have been a really good one because I understand how to combat fly like really, really goddamn well. Like I did a F-16 simulator. Part of the officer candidate program. It was so cool. Like we got invited to Miramar, so I went to Miramar. I flew an F-16 simulator, and I was so sad because I basically told the guy like this is just like Kerbal Space Program. He's like, what? I was like, yeah, this isn't that cool. He's like, what do you mean? Like, I didn't know how to combat fly then. If I knew how to combat fly, I would have actually like done more of like the throttle control. I would have shown off, bro. I would have been like, all right, what can this motherfucker do? I'm like, I probably would have cut the throttle, done full rudder, pitch back, and like I would have basically done attack runs, like just for fun. He probably would have been like, shut it down, like don't let him see the actual capability of it. But I put it into afterburner. I was like, this is just like Kerbal Space Program. That's sad. Bro, my top secret, let me see a lot of what the government is up to. Nice, man. Nice. Well, unfortunately, you can't discuss that. So I respect it, man. I respect it, but pretty much, yeah. The cool thing about physics is I don't need a TS. I don't need a TS to figure it out. Like if because my job shows me like I can see the analysis, I can see the wave functions. Um, I know how these mechanisms work. If I wanted to, I could definitely release some information that's like bad, but like hell no, like that's not good, you know. Maybe you can build an F-40. Well, that wouldn't be a bad idea. The F-22 is currently, I think the F-22 might be is literally unstoppable. That's something I wanted to make in a video as well. The F-22 is unstoppable in terms of like a radar attack. You can't track it. You can't track it. You can't be radar locked. It has to be visual lock only. So if you try to use thermal methods, oh yeah, the F-22, F-35, yeah, the F-35 like is actually a little bit better than the F-22. But the F-22 only because it has that freaking like the engine cover, the way the engines are like are covered and like even less like easy to track with thermal methods. The only thing is the F-35 can be tracked with thermal methods, which is old school tech. That's the only thing the F-35 has against it. Thermal lock. That's it. F-22 is unstoppable only because it beats thermal lock by being able to pull that Cobra maneuver and hold that hover like that and then get lock on the enemy again. That's why the F-22 is just too damn deadly. But theoretically, if the enemy, and this is what I didn't want to discuss just because like I don't want to hurt our people. Didn't know that. Yeah, because you know how the F-22 engines have like that, like kind of like that curved inward. It's real, like it's hard to have visual on the thermal from the engines. You have to be on the 6 if you want a thermal lock on the F-22. Or you can also attack the F-22 with a line of sight, but it has to have like your camera, your sensor has to be tracking the F-22 via line of sight. And that's also hard because the F-22 could easily just change its combat style to night. And if its combat style is at night, well, even with thermal methods, it's hard to track that mother. So the F-22 is damn near unstoppable. That's why I think it's actually beautiful. It's one of the most beautiful aircraft ever designed because you can't radar lock it. Well, you could, but you basically can't radar lock it because it has the absorbent materials. The F-35 can't be radar locked either, because it has absorbent materials. So I would not fuck with any nations that have F-35 or F-22. You can easily get blasted because those guys can fly at 10 kilometers and then fire the air-to-ground missiles. You'll die. They don't have to fly low. F-22 is a bad bird. Yeah, they're not what's it called? They're not the best maneuverable aircraft, but they're not target trackable. They're not radar lockable. That's their advantage. They don't have to be like you also need to understand doctrine. F-22 flies. I'm guessing. I'm not an expert, but here's what I would do as a physicist. One squadron of F-22 or something like that. Like 3 of them ground level doing attacks. 3 of them sky high altitude. So your 3 of them doing ground level, doing actual dogfights, radar locks. Your ones up here, radar lock your enemy from easy distance. Gets them. So Soviet didn't break up. Would they develop better jets than the US? How many nations have F-22? I think only the US has F-22s, and I think Israel. If Soviet didn't break up, would they develop better jets than the US? That's a good question. The Soviets did have really powerful jet engines, and I think the Soviets would. Here's the thing that's interesting about history. The guy that developed the radar or the radar absorbent material equation that could actually have like nanostructures that could absorb radar, he was Russian. I remember my physics professor mentioning that. Oh, he was Russian. Like if his equations were actually taken seriously, the Russians could have had like a stealth fighter by the 90s. It was my professor, Professor Corbin. Yeah, they did have some sick-ass engineers, man. Like, it's not impossible. But what would have held them back, I think, was their laser etching. That is what would have held them back. Because in order to make the surface coat, you have to laser etch to make these tiny nanostructures that have just enough height and width and space between them that any radar waves that go through them get absorbed. That's the beautiful thing, that whatever you shine at my coat gets absorbed into my coat. You can't even target me. So yeah, I really love the F-35 and the F-22. Like, that's why I designed a very basic camera system that can be coded into an Arduino. But I don't want to release that because it's like, dude, like, why am I trying to hurt my own troops, man? Like, I love my pilots, you know, like I worked with them. I worked with helicopter pilots, and they have a different doctrine than fighter pilots. Helicopter pilots fly at a distance, and they pop up, attack, pop down, pop up, attack, pop down. But it's not just the same ones. Su-57 is a weird technology. I believe it comes from Iran. Iran was like one in technology. My dad was an officer, but I went and enlisted. Respect, man. Yeah, I went and enlisted too. Could have become an officer, but I was like, nah. Want to be a civilian, smoke weed, but I can't now because I'm like, I have a clearance, and turns out, you know, like federally that shit's illegal. So man, I can't do it anymore. So whatever. I think the Su-57. I was actually researching that. I don't think the Su-57 is going for a pure stealth method. I think they're going for like the F-117 method, where they're not actually doing stealth. They're doing reflective coating. Like, they went for pure titanium. They went for titanium. They said, "Fuck it, bro." Like, because that thing can go Mach 5 plus, allegedly. I think in reality it can go Mach 4. I don't think it can go Mach 5 unless it has altitude. Which, why would you want to go altitude? Terrible idea. So I have it in my notes, in my engineering notebook. Let me bring it over here. But yeah. Okay. Yeah, I drew the Su-57, and I was basically talking about its downsides. It has hard points on the bottom. It has clear engine stuff. Like, on the bottom, if it does a Cobra, it's easily lockable. If it's flying straight, it is not easily lockable, only because its angles, its surfaces are reflective at pretty much good angles. You would have to have 30 degrees on it. When did At the Ligma Systems TikTok get deleted? Honestly, I have no question. I have no answer. That's a good question. I don't know when his got deleted. Yeah, I know what it did. So yeah, I'm feeling the wine, man. Did the SU achieve quantum gravity with it flat spline maneuverability? No, quantum gravity definitely not. But the Su-57, okay, it has fine pitch and it has main pitch. Just what I've been looking at its design. So it has main elevators, it has some edge elevators, and has obviously like the tail ones, which could be used for elevators. The vulnerabilities for the S-57, like an Su-57 is a low-flying aircraft. Always. It has to be. If it flies any altitude higher than like a kilometer, you can easily target it from the bottom. The bottom has such a large radar signature, but the top is basically like is meant to be like reflective. Like it basically bounces off. You're gonna get very little reading back. You will get some, but very little, because I think they went for a pure reflective coat method, where they wanted everything to just bounce off at bad angles. They went F117. That's all you gotta know. They went F117 route. They did not go F35 route because they do not have reflective coating or radar absorbent materials. They don't have that technology. Will we ever get close to the speed of light? I don't think so. Unfortunately. You can get like 70% speed of light, but only with, like we said, the laser assisted light sails. That's possible, and I think that's freaking awesome. Can we develop more destructive stuff than nukes? That's actually a really good question. Yes, but it would not be droppable. I don't think it would be airdroppable. I think we could theoretically, in my opinion, develop more. My nephew is in Air Force. So I try to keep up with other countries' technology, especially during war. Yeah, man, Su-57. Like I think they fly low, and I think their main attack is to kind of pitch up, target lock, fire, and then keep flying low and flat. Su-57s cannot. They would never risk flying high unless they're in their home territory. I think Su-57s are basically low flying striders that do their bomb runs and they fly back. I think Su-57s are very, very what's it called? Defensive fighters. They are not offensive fighters. They're bombers. They are bombers. They're perfect at what they do though. Fly fast Mach 2 while bombing. Fly back Mach 3. Alright. Can we develop stuff more destructive than nukes? Yes, but I think it would not be efficient cost-wise. I think we would have to use, like quark collisions. You would have to build an entire collider and then detonate, and then like fire your particles that would have a reaction, and then those particles would react with other atoms. I've heard someone mention lithium deuteride. That is possible. If you wanted to, you could use the LHC to make a really big bomb, but no one in their actual civilized mind would do that because you would waste all that money building the collider just to create an explosion. Why would you do that? Do you think physics will ever become obsolete and redundant? Obsolete and redundant. That's a good question actually, because I think physics actually that's the weird thing, man. Like we could theoretically create software that has enough considerations that we don't necessarily need it too much. Will it ever be obsolete and redundant? No, not to the degree as other jobs like artisans or even doctors. Doctors can become redundant, but you still need people that need to understand these practices. So doctors will become technicians, physicists will become technicians, engineers will become technicians, even musicians will become technicians. Any professional skill will become a technician-based job where you just have to understand the theory and understand how to utilize these softwares that are with that. So yeah, with the new tech and physics, we should have the ability to create weapons stronger than nukes. Yes, definitely. But I don't think that's right at all, because you what, you want to invest $1 billion just to drop a bomb that's what? Okay, let me estimate. Okay, so the biggest bomb ever was the Tsar Bomba, 500 megatons of TNT explosive equivalent. If we used like an antimatter matter like infused explosion, and we used the best material we could, and we know its decay depth, like how far it can go before the energy's like run out, we could probably make an explosion instead of 500 megatons, maybe about 5 times that, maybe 2.5, tetratons or something, maybe 1 tetraton, something like that. Not megatons, but maybe begatons, like billions. Isn't it weird that our country has run off oil and power? It is definitely weird, because we are pretty far along society and civilization that we don't have to do that anymore. And it's very upsetting and disappointing that we are actually still running off fossil fuels. Like, we have the technology, we have nuclear energy, fusion. I think fusion is possible only if, and it's funny, we've been using machine learning, but machine learning is not the solution, because you need actual physics in order to utilize machine learning to its best capability. So I think all these people using machine learning to brute force the answer to fusion physics are retarded, and they piss me off, because that's not how physics should be done. We should not be letting computers just optimize the solution. That's what I'm telling you, that all these quantum physics people are actually, they piss me off. They piss me off. All right. So could the future of physics be taken over by AI? That was something I was actually thinking about. Like, would it be possible for us to develop a scientific inquiry, or an AI that's like asking questions that continuously improve itself, that can actually solve physics, solve answers? Like, the thing is, physics could be taken over by AI right now because of how physics is being done. You know how I just said how they put a perturbation and a fucking answer like that? If you let a computer find the perturbation, or the perfect perturbation, physics would be over. We don't need experimental physicists anymore. It'd be like, oh, the perfect perturbation is 31%, 31.3%, whatever the fuck, Add a 31.3% perturbation for the energy, and that just solves it. That's not necessarily the utility. Even then, you can have some sort of algorithm that can then guess, okay, based off this, what if I input a sine model? What if I input a x model? What if I input a sine x squared model? These models are not impossible. And honestly, these models are all within. You will never find a physics equation that has more than sine times cosine. In terms of stuff, you will never find a sine to the 5/3 times cosine hyperbolic to the 3/7. That will not happen. Most physics equations are pretty much straightforward, where you can kind of figure it out. You're like, oh, of course this model would be oscillating at the rate of sine squared over x squared. Of course it would. You will see that, and it's not that challenging. But if you use a perturbation model, you'll say, of course this particle is oscillating at alpha means coefficient, alpha 1 times 1/2, which is the kinetic energy equation, times sine squared times beta times x squared. They add extra stuff, most of the time. Money is the answer. Could people find themselves in position of power always? Yeah, corrupt people always do find themselves in position of power always. I process lithium as a civilian job. What's your take on consciousness? Consciousness is really, honestly, just what's it called? Is binary information. My brain can be tracked like this. Your brain is a matrix. If we could break down your brain as a matrix that's what's called a rapid access memory. Your RAM is what you're thinking about right now, and whatever's stored is like the outliers or the edges of your matrix. All right, I gotta chug this second or the third glass. I've only had 2 glasses so far. This bottle has only been 2 glasses. Yes, but consciousness. No, consciousness really is bitwise information. Yeah. So, good question. Yeah, this is a genuine question. Consciousness is just bitwise information. Like, it's everything that you consider yourself to be. Man, male, universe, United States, citizen, Hispanic, your name, your location, country, state, origins. It's basically everything that cascades, everything that is from you outwards. Your consciousness is just bitwise information patterns. It's actually not impossible. Your brain, honestly, I don't think your brain should be that difficult to chart. What is difficult to chart is the analog memories. Yes, the analog memories are difficult to store. But in terms of what you are, that's not too difficult. How smart can one person be? Is there any limitation to that, or is it free training? Good question actually. How smart can one person be? I think one person can be as smart as they want to be, and they can study as much as they can. And what really matters is if they understand how the actual function works. Smart is a weird word. It's a weird word because not everybody is smart. You can have knowledge, you can store knowledge, you can be autism, you can be really good at storing information, but you're not smart. You're not going to be able to contribute things. I think there's kind of 3 types of people, and based on what I'm talking about with physics, there are technicians. There are people that are really good at what they do, but they're like, I'm a PhD physicist. Well, what do you do? And they're actually kind of like they're what we. I'm gonna talk about the elites before I talk about my perspective. The elites would basically see these PhD physicists as slaves. I'll just say slaves. I won't say the rude word. They are slaves that are just trying to design the process. You are a slave that are building our CERN device that are basically enhancing our computational depth because you think you're better than the average person when you're really not. You're just as much of a swine as the average peasant. The only difference is you think because you know some math and some basic stuff that you really don't understand. You're like, nobody can actually understand these particle physics. All these particle physics are actually impossible to know. Just calculate and integrate. Go fuck yourself. Truthfully. Please do. Because you're not worth anything. Then there's actual physicists like, Isaac Newton, Albert Einstein, that actually advanced the field. They're not just slaves. They're actually trying to understand, hey man, what is integration actually doing? What is this differentiation actually doing? Why are we just using an approximation of a perturbation model? Why? That's not necessary. Let's find the exact solution. But these pussies, these jabachems, those people, these people that are like these average, basic, slave, PhD physicists, you have a PhD, but you're not contributing to research. You're just being a technician slave, in all honesty. You think you're better than a technician, but honestly, you're not doing shit. You're just saying, tune the cables to this value. Do it. That's it. Next thing. Let's keep answering these questions. Have you ever considered going back to school? I will. I'm gonna go back for a PhD or I'm gonna try to do a master. I don't want a master's. I want a PhD straight to physics, honestly, because I think I'm PhD qualified, bro. Fuck these people. Have you read any David Bohm? No, I have not. So everything is conscious. Technically, if you think consciousness is like observation, I think consciousness is like changing states. If something can change states, it's conscious and it can store it. If it can store states, yeah, it's conscious. Consciousness exists outside of the body. Yes, it does, because of how states are stored. Is memory stored outside the body? Technically, because everything is analog. That's what's beautiful about physics, is like there's analog and there's digital. Digital is the binary stuff that we saw. I can create like a freaking table, like a punch card that can generate everything about you, but it doesn't have you. We still need the analog waveform to put it in to make all that work. It's weird. How does consciousness exist outside the body? I think it exists outside the body in terms of information, in terms of how, if you were to continue the wave function at a certain rate, then your brain would work. That's sort of how I think we actually estimate consciousness. We estimate consciousness based off some perturbation of time, some flow of time, and we assume the wave functions develop and interact with each other at a certain way that comes out with you. That is what we pretty much do. We pretty much time step wave functions forward. Why do you think dreaming exists? It's actually happening. Why do you think dreaming exists? Your thoughts create reality. I think dreaming exists as a way to simulate, our fears. Our brain has bitwise, these are my fears. And your then actual brain is like, how would I simulate these fears in order to solve them? How would I solve these problems? And your brain is kind of just doing that for you. That's one aspect of dreaming. Like it really is trying to feel your internal states. That's why I think dreams pretty much are you're just your internal states. Yes, you're referring to mindset. Yes, otherwise I don't know. Oh, dude, Dave Bohm is mandatory. Kind of like what the Germans did to Heisenberg. They made him a worker bee. Exactly. So yeah, like physicists often get like forced from like, dude, you're the next genius, to like, okay, genius, can you design the next machine for us? Be like, okay, but I shouldn't be doing that. You should get some other PhD to do that. Be like, no, they don't understand it. You need it. Be like, okay, fine, sure, I'll do it. And then once your machine becomes standard, then the next generation assholes be like, the next PhD Jabbachems. The next PhD Jabbachems will basically be like, you see this particle accelerator right here? That's physics. Yeah, fuck that guy. He's not a physicist. He's an asshole. I hate him. Let's talk for a little bit. My phone's gonna die in 15 minutes. I kind of want to like beat this shit, man. Like, yeah. What's up? Why do they agree? Money? What do you mean specific? Why do they agree? Do you mean like why do physicists like accept slavery? Well, yeah, definitely the money. They're like, oh, I'm getting paid $180,000 a year. I'm getting paid $250,000 a year. I'm getting paid $300,000 a year to basically keep some top secret information, and to basically the thing is, like, the thing that's really weird, that I find so weird about like all these government contractors, is like, you always hire the wrong people, is what I've noticed. Like, I've never seen, in terms of my line of work, like, I haven't seen someone that's like, damn, this person's like a really like, this guy's a fucking genius. Like, damn, he really earns his money. Like, every time I've seen someone, I'm like, so you're getting paid how much? 170,000, and like you think you know everything? Bro, your answer's fucking wrong. Like, honestly, like, what do you mean, bro? I have a master's degree in engineering, and I'm a fucking me. Like, I have a master's degree in business, like administration. What the fuck do you know? I'm like, like, are you considering the electrodynamics? And then they shut the fuck up, and they're like, electrodynamics? I haven't done that in 27 years. And why the fuck are you like, I don't know, kind of like doing electrician technician work? What's wrong with you? Yeah. So reality is only as you see it as real. The current moment will only be the thing that truly exists. Try staying in the moment. Pretty much. But the thing about that, it's a little sad as well. That the current moment is all that exists. But let me try to think about it. So reality is only as you see it as real. The current moment will only be the only thing that truly exists. Try staying in the moment. Yes. If you go into the past, that's just bits. If you go into the future, that's bits of what could be. The current moment is bits that are. It's a beam that shines in every direction. The uncertainty principle, right? The uncertainty principle. Okay. Well, just answering your comment of the current moment is the only thing that truly exists. Yes, the current moment is the only thing that truly exists. Prerequisites for getting into physics, in my opinion, have a really inquisitive mind. Always be able to ask questions, understand things. The only prerequisite for physics, I would say, is a strong basis in you don't even have to be that strong. You have to know Calculus 1. If you're really good at Calculus 1, everything else will be okay, in my opinion. Because Calculus 1 teaches you about related rates. It teaches about, you understand, that sliding ladder problem of related rates? That's everything. That's pretty much all of physics. When you learn about triple integrals in Calculus 3, you're like, oh, that related rates problem? That's one of the hardest problems you'll ever do. And I say that because everything is actually given to you. The only time things get hard is when you're doing differential equations. Differential equations is reality. But Calculus 3, just always tell yourself that the equation I'm given is elementary. It can be broken down, and everything is directly related to one another. So z is a function of xy. Y is a function of x. Build up. All you got to do is just translate these things. What am I curious about in physics currently? I'm currently curious about information theory, and I'm currently curious, information theory is just stuff for the future. But I want to see the fruits of the Standard Model now. It's possible. What pisses me off is that we live in the future now. I'm a physicist. I get to see the future. You don't. I don't know what you guys think the world is, but I see the world as electrodynamics, magnetism. We can engineer all this shit. Anytime you see people that talk about solar panels and all this stuff, I made a solar panel that then powered my engine because it uses an AC/DC motor, that's trivial. Mechanics, trivial to physicists. We live in the future. So whenever, that's why whenever I make comments, it's you even saw my video. If you see my video about the weird classified conversation, basically I'm talking about the Petra process and PLC. You see these radiochemists that are this is just simple radiochemistry. Be okay, radiochemist, but the average person doesn't realize that, yeah, we're living in the fucking future. We live now. We do have access to topography. We have access to the thing is, as a physicist, we get told what exists, and we get told okay, that exists. This is not at your disposal. This is not at your disposal. Like I said with the radar thing, with the radar absorbent material, because we have laser etching devices, we can make nanostructures that now absorb radar. No waves can go into this freaking mesh because the mesh is with nanostructures that are spaced out mathematically with structures to absorb all the different wavelengths within operating functionality. Try letting the thoughts flow in without question. Exactly. That is what I'm doing. I'm basically saying that, like, the thing that pisses me off is that every time I talk about anything about physics, like, oh, well, this is how radar absorbent materials work. There's always going to be some asshole out of nowhere that's basically like, we've been doing this shit since the 80s, bro. Since the 90s. Since the 70s. Be like, yeah, so what? My physics professor said, like, the CIA's been doing this shit since the 60s. So? It's for the public. Taking with others, my bad. Any entry-level recommendations for any entry-level books, recommendations for understanding physics? My biggest recommendation is Walter Lewin. Look up 801 Walter Lewin Physics on YouTube. 801 Walter Lewin on physics. Physics on YouTube. 801, 803, 802. 801 is classical mechanics. 802 is electrostatics. 803 is wave mechanics and a little bit of electrodynamics. Beautiful stuff. His 803 course was actually a little bit of our upper division electrodynamics, a little bit. As well as it had wave mechanics from it's beautiful. If you're ever taking a physics course, go through his lectures, use what applies, and just keep going, man. Like, it's beautiful. He actually teaches physics. He's really good at it, man. If you want to look at his homework stuff in the bottom, he has homework guides of problems he does, test guides, and pretty much if you look at his tests, that's pretty much kind of the tests of UCLA, honestly. So physics 1B and 1C, yeah, look at Walter Lewin's test guides, pretty much exactly what you'll be doing. Interference and stuff is so fun. Dude, I can show you right now, I was ass at physics at first. I wasn't ass, but I was not a straight A student. Let me bring up my test. I got a freaking 82. Not 82, I mean a 12 or something. Okay. For particle physics, will I ever teach one day? For sure, man. For sure. I'll teach particle physics. This is shit. This is terrible. This is particle physics. Where they try to basically tell you that there's this and just know the numerology and phases. They work. This is called hypercharge. Hypercharge is dumb. Let me show you what I did. Okay. Find what this is, man. So yeah, I have some random papers, man. This was a physics exam. This is that K-meson I was talking about, right there. So you have an anti-up and a charm. I broke it down correctly, used my revision to the standard model, solved the answer correctly, got the answer. Here's a different charge particle reaction, solved it correctly using my model on the fly. The funny thing is, I told my professor, my model can solve any of your, I solved a upper division physics class, not giving a fuck, not studying. Because I was like, dude, I don't have to study because I know the fucking rules. He's like, you have to know how the weak force breaks down and converts particles. Be like, I don't like that you just say up becomes the other one. Fuck that. Charm becomes the other one. Fuck that. How do you know? It's not guaranteed. He's like, oh yeah, you gotta make sure your your charges all hold. How do you know the charges are gonna hold, bro? Because you got to do your calculations. Like that's stupid. All right. Yeah. More of the particle physics exam that I basically did. The strongest shape, I think the weird thing is, it might be the trigonal pyramid, the trigonal tetrahedron. Trigonal tetrahedron might be the strongest shape, in my opinion. Can you explain entanglement? Entanglement is where two particles, like, they share information. Okay, here's another thing. Yeah, right here. Here's a top. That's a top and an anti-top exchanging a photon pair and decaying into a down anti-down. That's dumb as hell. Entanglement. And is it related to information theory? Entanglement is keeping two states or keeping a system at such a low noise level that any perturbation or any disturbance in any one single segment of the information or single segment of their chain causes them both to react. Entanglement, in reality, let's simplify it. We're not going to be retarded. We're not going to be PhD assholes. We're not going to obfuscate it by basically saying entanglement is the manifold of the quantum electrodynamics and chronodynamics. You need to understand the theory. No, you don't. So entanglement is basically saying if we have a system that's in near perfect stability, we have it cooled down very well. We have the system where they're basically just each other. If there's any outside disturbance to the system, if we have a photon or something that bounces on the between the chain of both of these particles that are entangled together, the one on the left will excite and the one on the right will excite too. That's why you can actually shoot something kind of between these particles to heat up the system, cause noise between them that can excite the left and excite the right. Theoretically, you might be able to use entangled pairs to send information, but only if it's not sending information, it's only reacting to information. That's all you can do with entangled pairs. So whenever people say like, well, we can't send information, true, you can only react. So CERN sort of entanglement. CERN is just calculations. CERN is just doing calculation research, calculation depth research. Can you not anticipate the future without wanting to learn? So can you not anticipate the future without wanting to learn? Yeah, you can anticipate the future. You can. But you can basically say, hey, I sent a signal. Did you see that? And you're like, oh, I did see it. That's all you can do. Can you respond faster than the speed of light? No. So if I disrupt this pair and you see an update on your system, you can just say, oh, my friend sent me a text message. Do you know what it was? No. But if he said, I will ping you, if you can basically be a Paul Revere. That's all you can do with quantum pairs. It's up to you to figure out how to use Paul Revere's message. It's like, I will signal a fire if there's the British, and you're looking at your particle, you're looking at your computer system, and it's blank. All of a sudden, you see a ping, and you're like, whoa, Paul Revere sent a signal, bro. That is the purpose of quantum entanglement. In the future, that ping will be used to reconstruct the clone, like we said earlier, for quantum teleportation. But for now, it's just Paul Revere. It's like, whoa, he lit the flame. The British are coming. That's all you can do with particle physics. So actually, I should make a video about that because people don't know all these physics, like the no clone theorem. Like, yeah, you can't clone. Yeah, you can't like. What you think the candle guy could light a fire faster than Paul Revere could? Like, you get me? That's all it is. You can see the Paul Revere, you can see the torch, but you can't communicate faster than lighting a torch. You get me? That's all it is. So if there's another me somewhere, we're connected through entanglement. No, you're not connected by default. You're not connected by default. You're only connected if there is no noise at all. There's no outside signal at all between you and another system that can occupy everything that you can. What happens after death, my friend? I think after death, your signals of your brain just stop, and whatever you had, whatever wave function you had, like that's you. It's gonna slowly fade away in terms of this world, but in terms of information theory, it exists forever. So like the alleged like truth between like like I've done some research on like what people claim about aliens and stuff. The alleged thing that happens, or what aliens claim, is that when you die, what you want to do is actually understand people, so that when you die, like if suppose you, I'm trying to recreate you, Ryan Ski, in my life. If I died right now, I'm like, man, I really wish I could talk to Ryan Ski again. I couldn't recreate your consciousness correctly. I could only recreate your consciousness to the degree that I knew you. I will always exist. My consciousness that I remembered will always exist in that state. The thing is that why aliens don't encourage suicide is because if you die, well, you would only be able to recreate people to the degree that you knew. And that may not be satisfactory. It may not be pleasant. Because you'll realize how little you actually knew people. Because you're like, I don't want to hear you keep asking these things. I want to hear you say these things because, like, that's not a person. That's not you. I want Ryan Ski. I don't want some guy that's asking me what happens to death after, my friend, and does consciousness exist. So you recreate yourself. I don't think you recreate yourself. I think you really just live. You really just live. What's it called? You live. Like, you just exist. You can do whatever you want within your brain that you know of. You can recreate anything that you know of, but the problem is you get to live forever, but you don't get to live new. You get me? You can eat whatever you've ever wanted. You can do whatever you've done, but the sad thing is you can only do what's within your mind, what's within your capabilities of what you knew. That's why people will eventually like reincarnate because they're bored. They're like, man, I only can imagine these things because when I was alive, I could only have imagined those things. So it's free space to do whatever. I think it is a free space to do whatever, only within whatever of that you can imagine. So what was I before I came here? Before you came here, you were nothing. You were just information. You chose to like reset your brain. You chose to reset everything you ever knew and basically say, fuck it. I'm trying to learn more bits, more about the universe, so that when I die, I can generate whatever I want. That's what the alien like theory of reincarnation is, where it's like you want to reincarnate, you want to live, so then when you die, you can generate whatever you want. That's the purpose of meditation and thinking and love. Get to know people so that when you die, you're like, oh, cool, like I actually understand them, But if you don't actually understand people only on a surface level, then people only ever talk to you the way you lived with them. Like I was never deep with people, not me, but suppose you were never deep with people, you basically be like, hey man, like, how does infinity feel like for you? Like, we're just alive and we never die. He'll be like, what do you mean? We're not infinite. We're gonna die soon, man. Like, you get me? Like, no one would be able to converse with you. So you'd be stuck in an infinite hell. It's weird. It's weird.
have you seen the similarities between physics and Buddhism or Hinduism? I have actually. I do agree that there are similarities, only on the fundamental level in terms of like fundamental information theory and like binary universes and stuff. That's why I think binary universes are my theory of everything. Like ever since I adopted the binary universe model, everything has been pretty simple, honestly. Like that's literally what happened and how I solved my gluon pair thing. I'm like, gluon pairs are so fucking annoying because they're just quark anti-quark. I'm like, why? That's dumb. Two protons come in, they emit a gluon, and then they come out as quark anti-quark. I'm like, what the fuck is wrong with you? I hate this class. How old am I? I'm 23. You should check out the holonomic brain theory. I would love to, man. I would love to. Yeah, I got a drink. The reason I have my phone like this instead of having it over there is because I had to charge it. It was at 5%. This is the last bit of the wine, man. Ooh. I'm not gonna look forward to that, man. It's only been 2 glasses. Ugh. Any last questions? Jeez. Alright, this is my chaser. I'm gonna drink my chaser afterwards, man. Ask questions real quick. Ooh. You. Yes, I want to meet in La Jolla, man. I don't mind. Yes, I'm using a chaser with wine. This is I think it's $25 wine. Yeah, it was reduced in price at Ralph's for $19. It's $25. It's not as bad as like $8 wine, bro. Yeah, I need a chaser. Ooh. Bruh, you were only 3 years older than me, yet this smart. I have failed in life. No, you haven't, man. Don't ever say that. Don't ever say that, man. Life is like, you didn't fail. Everyone failed you. Honestly, everyone failed you because no one told you the truth. No one fucking like explained the world to you. Like, I have to become my own dad. Honestly. That's sort of like the spiritual stuff that I realized, that it's like you have to become your own father. You have to become your own person. You know, you got to become a better man. Like all this stuff. Like I can finally work out. Like I have money. You know, I can eat food. I can buy scallops if I want. I did buy scallops, bro. Like it's delicious. So yeah. How can I catch something without thinking about it? How can I catch something without thinking about it? Good question. Can you clarify about that? Can you clarify that real quick? How can I catch something without thinking about it? So yeah. I want someone to love, man. That's all I care about. Honestly. Yeah. I'm a normal person, man. Like I really give no fucks about physics, honestly. When did we become information? You've always been information. You've always been information. Your brain is literally just categorizing like the world. You are just what you think the binaries of the world is. If I thought I was a cat, I'd be a fucking idiot. But my brain would say I'm a cat. Like boom. My brain has binary of cat, and I wouldn't be able to function in the world. But the thing is, I think every brain, every information system is just trying to understand the world within its little construct, within its little reverberation. Like, you know, that I have a video on it. Like, look at my most recent video where I talked about like the recursive model of the brain. I didn't talk about my professor, about how he explained linear processes and wave-like processes. I do have to do that. So I'll write that down right now. But yeah, I'm gonna do that at work, just because we have so much free time at work that it's pretty fucking nice. Most of the time I'm looking at TikTok,
but I feel no fulfillment from that. You know, like a lot of things don't fulfill me, and shit, you know, life is pretty sad. How long have I been in physics? In my opinion, in my feeling, I've been in engineering, like problem solving, since I was young. But in terms of physics, in terms of like a more professional nature, since my undergraduate year. So once I started seeing physics, I was like, damn, that's fucking cool. So I've been in physics since 2018. Um, Professionally, I've been in physics since 2021. So honestly, like fully trained 2021. Yeah, and so not too bad. You know, I've been a professional physicist for a year. Not honestly, like these people take themselves way too fucking seriously. Like like they're blind. They're blind to this world, and it's just annoying. What was I gonna say? Well, when it becomes okay, information, linear processes, lin process. That actually is a big deal. That's pretty much that actually might be the next solution. Um, Everything has this model, has this behavior. So lin processes versus wave-like processes. That actually might be the solution to photons that I've been thinking about. Okay, thank you. That's another thing that I've been doing. Um, you will need a long way to grow a bright future. That's all you need. Absolutely, man. I'm gonna use my job money to first buy a house, and then eventually save my money to get a master's degree or a PhD in physics. So yeah, because I don't need it right now. I can easily outperform engineers. That's the thing that's so funny. I'm like, damn, you head on straight, bro. You'll go far. Thank you guys very much, man. Um, this wine, I chugged half of it, so we're gonna try to finish the other half. As you guys saw earlier, bottle is empty. Damn, we had a good time. We had a good time. That was supposed to be for the evening, man. So yeah, I'll post this. I'll post this on YouTube. Yeah, yeah. Any last questions? Any last questions, guys, gentlemen? Uh, specifically on, I guess, posting. Yeah, because I do need to. So let me give one more clarification. Okay. Linear processes, wave-like processes, that is important. Post what I have right now on potentials in the Hamiltonian. Talked about quantum teleportation, about the issues of it, about how it's a Paul Revere-like thing. That's good. And talk about degrees of freedom. That's good. What's the next step in physics? I feel like it's got to be something with AI. Yes, it is. The next step in physics right now is with AI. Right now, what's happening is like what CERN is doing is they're trying to utilize the particle decay process. We realize that that's for everything. Everything is particle physics. So if you can write your function in terms of particle physics, and if you can discover your data how it matches particle physics, which I showed with the TikTok algorithm, it actually works perfectly with AI. That's the future. The future is using the standard model to, you know how machine learning, like if you look up machine learning, you're going to see a lot of dumbasses that basically say like, there's this weird like my model is off by 50% error. Be like, because you're not understanding your dualities. Like they think computers are like fucking what's called decimal processes. No, they're not. They're not decimal processes. Like they think like computers will like are not binary. They are binary. But these machine learning like software engineers are freaking stupid. They're not physicists. That's why if you ever see anything about machine learning and you see anybody that says like when your model is off more than 50%, unfollow. They're fucking idiots. They don't know anything about the field, honestly. I fucking hate that shit. So kind of more evidence that the universe could be a software of some sort. That is interesting. I don't think it's
it's a software, but I think it's definitely like everything follows these rules, and there's nothing you can do to stop them. There's nothing you can do to stop it because everything must follow these rules. Isn't that freaky? Even sentences, the words that I'm saying right now must follow these rules. Everything, everything. My hand must follow these rules. I can't hold my hand here forever. It has to go back towards what's comfortable. Order out of chaos. Yes, exactly. How do you think this universe was created? This universe was created from information rules alone. Do I think it was created from anything like physical and physics and all this stuff? Yeah, technically. But the weird thing is, all this came from information rules alone. Simply from the rules of information, this had to exist. That trips me up so much. I think about that all the time. I'm like, we had to exist only because the information rules. Like, we live in a binary universe, and so everything is electrical forces, everything is magnetic, everything is weak force. Please explain that more. So what I'm saying is, where do I start on information theory? I never read it. Information theory is sort of a new thing. I would recommend you read the Standard Model and sort of try to break apart any system you want. So I would recommend you first start with a simple algorithm or simple thing that you want to code for. Okay, I'll give you an example for you to practice. You can practice combat. Up, okay, up down is hard. Okay, combat's a little hard. Practice chess. Practice breaking apart chess in terms of up and down. Trust me, it's hard as an example, but if you can do that, you're gonna really be like, oh fuck, if I have this state, then I have my answer. Yes, you do. That's how that works. How was the universe created? The universe was created, okay, binary information. So what I'm saying is that based off the rules of what can be, that's what everything was laid into. I'm not saying anything. There's nothing religious about this at all. In terms of, damn, the last glass is starting to hit me now. That's good. That's good. I'm gonna be a little serious. Okay. It's really starting to hit me now. How do you think? Can I explain that more? The thing is, I've been through that so many times that I'm finding it difficult to bring you through the process again. Do you have any specific questions, brother? I'm genuinely serious. Do you understand what I mean by everything? Okay, so an atom is or it isn't. It does exist or it doesn't exist. For a specific point in space, there is an atom or there isn't an atom. Boom. Binary universe. Okay. When there's an atom next to another atom, the question now is, what is the quark content? The quark content is the Standard Model. The Standard Model is the up, down, and it's that binary array that I showed. It's the cascade. So everything, okay. Everything either is or isn't this. So usually everything is by the if. You see that right there? That's the if. That's where particles, that's where protons are. So if it is stable, then your output is limited. Your output is small. It's pretty much trivial. It's like if it's stable, the output's 1. It's a pretty much singular output. If the output is not stable, then you decay. That's the cool thing. That pretty much answers the question of how higher order things happen, which is why, like, the beautiful thing is that everything around you is stable. Everything is stable. This is stable. If I raise this, F equals potential energy equals mgh. I let go, it falls down. If I raise this, I let go, it falls down. There are fundamental rules to the universe. If then. Find these and realize that that's how everything is. We really do live in a binary universe, and it's fascinating once you see that. So yeah, jeez, this last glass is feeling. Yeah. Last questions. All right. Been here for a bit too long, I guess, for how few people there are. Oh, you. Binary wood duality and spirituality, same thing? Yes, they are the same thing, honestly. That's the thing that's beautiful about it. Yes, they are. Spirituality is just information theory. Remember that. So, male, female, positive, negative, everything that has duality must follow the particle physics laws. That's what I've noticed, and that's why nothing stresses me. Nothing stresses me out. Because I figured out how the particle physics work, how particle physics laws work, and now nothing stresses me, honestly. Like, in terms of life, in terms of love, even love, like, the answer exists. When I made a video that's like, there's only 256 possible actions, there really is. In terms of, like, degrees of freedom. We're not talking about specifics. We're talking about degrees of freedom. So at most, in terms of what directions you can go into, there's only ever so many stands. There's only ever so many, like, positions you can be put into. Right now, I am a teacher. I am teaching you. I am currently free-flowing. I'm actually looking at myself introspectively right now. I'm looking at this person named Isaac Bubbly on TikTok who's talking to you. I don't even realize that I'm not a human being. I don't even realize that I am a human being. I don't realize who I am. I'm just talking to you. I don't care about any of these intricacies. I care more about the information and relaying it to you. Do I care about the status of my eyes? Do I care about the status of my complexion? Anything about that? No. I'm just flowing. That is the beauty of information. How often do you stream? Not often, but I would definitely. Probably now I'll probably try to do it once a week, at least minimum. Because I think it's interesting. You guys have any questions? Yeah, I've realized spirituality is just symbolized and metaphorical physics. Dude, yes! Yes, honestly, you deserve a follow. Bless you, brother. You deserve a follow, because you understand exactly what I'm talking about, dude. Yes, it is exactly, spirituality is exactly symbolized and explained metaphorical physics. That's all it is. Metaphorical information exchange. Yes. All right. Yeah. Last questions for real now. I'm gonna go. I'm gonna start it back up in a little bit, but for now I'm gonna go. Last questions, gentlemen. Because the Buddhists were making these claims thousands of years ago. Exactly. That's what I'm trying to say. Like, what pisses me off is that we're letting life repeat. We're letting suffering repeat. And we're not realizing that we live in the fucking future now. Like, we have physics now. We have technology now. We can do it now. But it's like, someone else will figure it out. What do you mean someone else will figure it out? No one else will figure it out. Just do it. Do the damn work. It's not that hard. It's just electrodynamics. It's just information theory. It's just software. Just figure it out. It's not that hard. And that's the thing that I find is very fascinating. Like damn, like why, like our computer, like the thing that confuses me is what is wrong with everybody. Like our computer scientists, like okay, I'm not gonna say computer scientists. I'm gonna say CS majors. Are CS majors just stupid and like they don't actually know how to code? Because I know a lot of them basically just say like, "Oh my god, like I'm such an imposter syndrome." I'm like, so, do you understand how binary theory works? Of course I do. If true, then that. No, no, that's just AND logic gates, bro. That's just logic. But do you understand how to query? Yeah, of course I do. Be like, okay, then why aren't you understanding how machine learning works? Because that's like unknowable. Like, then, okay, okay, get the fuck out of here. Because you had to take a class in linear algebra, you had to take a class in mathematics, you had to take a class in discrete mathematics, you had to take a class and understand piecewise functions, and you still can't tell me how your threshold value is not or is giving you the wrong answer. Like, maybe your model is wrong. No, it can't be, because I'm using like Python fucking whatever the hell version. Be like, the problem is you're just using a library and you're not actually thinking about it. So, yeah, I have a lot of arguments and discussions with computer scientists, not computer scientists. Those are beautiful people. People that actually understand computer science are right next to physicists. We are family. We are family. The things that are not family are CS majors. People that get CS majors trying to become SWEs, software engineers. If you try to get a CS major, try to become a software engineer, why did you get a CS major? You honestly don't understand. Like if you go to UCLA and try to get a CS major, you will get reamed up the ass. They actually teach you computer science. They don't teach you computer engineering. They don't teach you software engineering. They teach you computer science. Forefront technology, new theory, most efficient practices. So if I hear anybody that has a CS major and they complain at all about their degree and they're like, I do Java or I do like fucking C++ and like I don't understand how to like move between indexes and stuff, be like, the indexes are day one. Like, I'm telling you, I don't know how to code in terms of your dumbass software engineering stuff, but I do actually know how to code in terms of here's what I need the reaction to do, here's what I know it will do, here's the equation, get it fucking done, you stupid software monkey. That's what physicists actually tell software engineers, if you want to know. That's what my physics professor said that we fucking tell software engineers. We're basically like, hey, bro, this is your solution to your aerodynamics equation. Put it in. And the software engineers are like, there's no way you can calculate an arctangent this fast. Be like, you dumbass, do you not know the approximation of the Taylor series? Like, how did you get here? You have a master's degree in computer science and you can't even do like a freaking Taylor series expansion? No, you don't get it because it's so complicated. Can you convert that to a coefficient polynomial? Like, this is what I'm saying, that a lot of software engineers, like CS majors, are just like cheaters. Honestly, they're cheaters. Don't trust them. Don't hire them unless they come from UCLA or an actual accredited university where that shit was hard. Otherwise, they should just be computer engineers, CE majors. If they're CS majors, I don't trust them. All right, that's it. Last rambling. See you guys.